Thank you very much, Jeremy, for this invitation. It's great to be here again. Great to see everyone and hear everyone in the audience, both new faces and new names, and also great colleagues as well. I was going to talk about a little bit about what we do, about optics or imaging in general, which is where we come from as a company, and myself and my co-founder as well, and how we're applying this into some opportunities in space. Um, so just a little bit of background of how we got into this whole space thing was, we come from a bit of a defense background, my co-founder and myself. Also worked a lot as a company in science and research, which gave us a lot of background and breadth of solutions for very different types of complicated imaging and photonic systems. And then we couple that with working in fusion and nuclear environments, and particularly in diagnostics for fusion, in to look into the in vessel, so the vessel where the fusion reactor takes place in future fusion reactors, gave us a lot of experience in harsh environments, which is one of the things that Jeremy mentioned in the beginning, which is quite true. We need to be able to work in harsh environments. So space kind of, we has a lot of those things, radiation, harsh environments, vacuum that we already had experience with, and that's how we got started in space. So I'll talk about really quick about some solutions that we have in SWIR, some that are, and then the rest, like I said, we're starting out in this. So in looking into long wave infrared, an example of a project that we just recently won just at the beginning of this year. I just mentioned a few applications that which will lead me into finally, what can you do for me and what can I do for you? The epic question. Okay, so this is when our heritage and our successful project that we did for the Astrophysics Institute in the Canary Islands, in December. The second version of our optics was launched with a satellite, giving excellent results. This time it's a bispectral imager. They're all in the SWIR range. And our customers are using this to detect levels of humidity. And these are actual images taken with our optics flying over the south of Spain. And it's absolutely spectacular. What they're doing is a comparison here between, I don't know if you guys can see my mouse, but anyway, the Sentinel on the left
We can
and
know this.
Drago so Drago 2 is the optical payload. That's what they call it. Our optics is the SWIR objective lens, 150 millimeter focal length. It's giving about 30-meter resolution on Earth, low Earth orbit. Um, for the cost, is what I always tell everyone, for the cost and time that it took us to develop this, the comparison with Sentinel that was, millions of dollars and many years, this took us 9 months. So I think the comparison is really, really interesting. Anyway, what they're really looking into here is, natural disasters, climate change. So in this particular area in the SWIR spectral band, they're looking at levels of humidity. So that's, we'll see as an application, things you can do, information that you need and you can get that other people will find valuable. Um, Humidity, agriculture, I'll show you a little bit more. So example one, SWIR. Then another project that we're working on and will be finished soon, hopefully launched in the next couple of years, is this one takes time because we have to find more money. But this one is working in the long wave infrared. And I really like this application because it's very commercial. It's for sustainable farming. We're working together with a great group of companies and research centers. And it takes into account the full chain, which I really love because, the first thing is, if you don't have a good image, we used to say, you can't get something where there's nothing there. So we got to start with a good image. So luckily, they'll still have a job for me. But in the end, we keep moving more and more into the value chain of now we got to get a good sensor and we got to start doing interesting things in artificial intelligence, training data sets, data fusion with other information. And one of the things that I really love about this is the flexibility and scalability approach that we're taking with this long wave infrared spectral imager, because it does have various bands. And that's going to be very interesting for helping push sustainable farming at a global level. And, you know, I'm a hardware guy, so I'll show you obviously some of the hardware stuff, which is really cool optics and optomechanics coupled with these. It's a three band sensor. This is a drawing, but we're actually making it now. And again, it's long wave infrared uncooled, pretty high resolution for a long wave, and really great on ground resolution. I think we're targeting less than 5 meters. So very interesting, very compact for the resolution it has. And we did a great work in really reducing that form factor. And that's another thing that Jeremy mentioned right at the beginning. Size, weight, and power is a big thing. Um, and then finally, am I doing on time? Yeah, good. So finally, the last example, where this is kind of combining those last two, because in this project we're working again. I'm showing most of the R&D things because we're looking into the future of Earth observation. So here, what we're looking at is shortwave infrared and long-wave infrared, and it has to be very small because ideally we want to use this for space. So we want this project to help increase production capability in Spain. The way to do that for us is how do we make space-ready series production? And that's something that we're looking into and investing in. And to give you an idea, if we try to fit something that's under a kilo so that it works, one of our challenges is to put this into a stratospheric globe, like a balloon. Sorry, in Spanish is globo, so balloon. We could use it for space, but that's really hard. The pointing is very difficult. So that's why I put on this. It has to be very lightweight and it has to be autonomous because there's got to be a whole bunch of balloons flying everywhere, or you could transfer that to satellites. We did some advances already. It's something we've already made. It's 150 millimeter as well. Very tiny objective lens, like literally like 2 centimeters. And it's very light. So this could be one of the solutions and could help towards that weight and power, reducing weight and power. And in this particular project, we're also mixing in integrated photonic chips for, we're looking into the back end of the processing. And I think that'll be very interesting to kind of, start mixing those things in terms of trying to save a lot of power. I think that the tendency is going to go towards onboard processing. And that's going to be where Keval's company is going to be very interesting because onboard processing, it's great. Everyone wants to do it, but it's very power consuming. And I'm really looking forward to working with Keval on that and helping advance in that area to really push that onboard processing. That's another part of this project, as well as with Morera and some other things that we're working on. So for me, I kind of see that the push in terms of more commercial applications that I kind of like are sustainable agriculture, which I mentioned, mining, which was surprising for me, but there's a interest in that, quite a bit of commercial interest in mining, archaeological site locations, which was also kind of interesting, using spectral data, really cool. And then I see there's a chat later on with much more experts than I am, of course, on greenhouse gas detection. So I'll be really interested to hear about that. I think it's great. Long wave and SWIR, that's going to be great in that area. And of course, natural disasters and climate change. And another one that I just like because it's fun is like looking at boats in the ocean and looking for pirates. So that's pretty cool as well. And with that, I'll finish up with the EPIC question. What can we do for you? As I mentioned before, we're a very fast and agile company in making optical systems for Earth observation. And I want to throw in there space situational awareness, which is something that is going to be quite interesting as satellites also need to see what's around them. And as there's more and more stuff in space, that's going to be more and more interesting. And we have already done some work on that as well. Image processing, which we're keen on. And I would summarize as like a full optronic product cycle. We manufacture products for our customers in series, and that's why we're pushing that, scaling up in production as well. What can you do for us? We're really keen on space qualified high transmission AR coatings. That's really important for us. And I put AR, but it could also be reflective coatings. Really interested to see stripe coatings for the hyperspectral or multispectral imaging on sensor. That would be great. And then back on the sensors, extremely lightweight sensors to match our extremely lightweight optics. would also be of interest for us. And with that, Jeremy, thank you for this opportunity, and thanks everyone, and open to any questions. Thank you.